AP Summer, this is Lesson 6 on acceleration. So what is acceleration? Acceleration is any change in velocity per unit time. The faster velocity changes, the greater the acceleration. The velocity can be changed by either 1, making the object speed up or slow down, or 2, changing the direction of the object. The units of measurement for acceleration are any unit of distance divided by any unit of time, that's velocity, then again divided by any unit of time. So it's a change in velocity per change in time. The most common unit of measurement for acceleration we use in class is meters per second, abbreviated meters per second, which is velocity per second, meaning how much the velocity is changing each second. In other words, think in terms initially of speeding up. That's the way we think of acceleration. So the velocity is changing, it's getting greater for every second that goes by. But it could also be slowing down or changing direction. The last one we'll talk about in a moment. Okay, so that can also be expressed as meters per second squared. So for every second that goes by, well, first the question is, what does an acceleration of 5 meters per second mean? Think about it, because that's kind of a confusing unit of measure. So for every second that goes by, the car's velocity has increased by 5 meters per second. That's what 5 meters per second means. So let's say at 0 seconds the car is not moving, it's going 0 meters per second. So it begins at an initial velocity, v0, of 0 meters per second. After 1 second, the velocity has increased by 5 meters per second. That's an acceleration of 5 meters per second. So now it's going 5 meters per second. How fast will it be going at 2 seconds? Well, after 2 seconds, the velocity has increased by another 5 meters per second in that interval between 1 and 2 seconds. So now it's going 10 meters per second. So that's what acceleration is. It's an increase in the velocity, or a change in the velocity. The formula for average acceleration is acceleration equals final velocity minus initial or starting velocity divided by the change in total time. So you see the formula there. A equals Vf minus V0 over t, or a way you can express the change in velocity is delta V, change in velocity. So Vf is final velocity, V0 starting velocity, and t is change in time, how much time elapsed. So example of acceleration. When this roller coaster is at the top, it is going 0 meters per second. So we'll say it stops for a split second. After 3 seconds, it has sped up to 15 meters per second. So what is the average acceleration? And by the way, the only kind of acceleration we'll ever deal with is average or constant acceleration. We never have changing acceleration, even in AP physics. So A equals question mark, that's what you're trying to find. What you're given is a final velocity of 15 meters per second. The initial velocity is 0 meters per second. And time is 3 seconds. So you have a formula, you would find this on your formula sheet, that is A equals Vf minus V0 over t, and this is just a simple plug in the numbers problem. So it would be 15 minus 0 over 3 seconds, or that would be an acceleration of 5 meters per second. So think about it. At 0 seconds, it's going 0 meters per second. After 1 second, it's sped up by 5 meters per second, so it's now going 5 meters per second. After 2 seconds, it's going another 5 meters per second faster, so now it's going 10 meters per second. And at 3 seconds, what this problem is asking for, it's going another 5 meters per second, so now it's going 15 meters per second, which is what the final velocity was. You can change velocity also by changing direction. So this race car is going in a circle at 80 meters per second. Question, is its speed changing? And the answer is no, it's going 80 meters per second. Next question, is its velocity changing? The answer is yes, its direction is changing. A change in direction is a change in velocity, because velocity has a direction to it. So if you're constantly changing direction, going in a circle, you are changing the velocity. Question, is it accelerating? The answer is yes. Any change in velocity is an acceleration. So if the velocity is changing, then it is accelerating. We can see the relationship between acceleration, 5 meters per second, the time, and the instantaneous velocity, how fast it will be going at an exact moment in the future. So VI equals AAT. So the acceleration is 5 meters per second. So after 1 second, it's going to be going 5 times 1, or 5 meters per second. After 2 seconds, it's going to be going 5 times 2, or 10 meters per second. That would be the instantaneous velocity at each of those times. So Laura begins from a position of rest, V0 equals 0. She accelerates at 4 meters per second. How fast will she be going after 3 seconds? So VI equals question mark. Acceleration is 4 meters per second. T is 3 seconds. There's the formula. You plug in the numbers and she'll be going 12 meters per second after 3 seconds. This is red. Laura's instantaneous velocity at 3 seconds is 12 meters per second. What if Laura is already moving at 2 meters per second when she accelerates at 4 meters per second? How fast will she be going after 3 seconds? So now we must add the speed she is already moving to the final speed. This beginning speed is V0. This changes our formula to V instantaneous equals acceleration times time plus initial velocity. So there you got the formula, and you add the initial velocity there. So there's the formula. So you add the 2 meters per second to the 4 times 3, and now she's going 14 meters per second. All right, and that takes care of this brief lesson on acceleration.